Hi friends, let us prove one very important theorem in triangles. That is, to prove medians of a triangle are concurrent. Concurrent means they pass through the same point. There are three medians to a triangle, right? We have to prove that all three pass through the same point. What is the median? Median is a line drawn from a vertex to the center of the middle of opposite sides. Right. For example, this point is middle of AB. This point is middle of BC, likewise, from the vertex to the middle of the opposite side. Now, these medians, they meet at a single point. This is what we have to prove. And once they meet, this point divides that median in the ratio of 2 is to 1. This is 2, this is 1. This is 2, this is 1. This is 2, this is 1. Right. We have to prove both of this. This is very important theorem in geometry, triangles. Let's see how do we do this. Right. So, to prove that all the three medians made, first let us take two medians, right? And draw a line through passing through that point to the meeting point of these two medians and prove that the line is actually a median. For example, BY and CZ, let these two be medians. Then we will prove that this point, whatever it is, this is the centroid, and the line connecting A and the centroid is actually a median, which that means this X is dividing B and BC into halves. Right, Bx equal to Xa. This is what we will do. Right. First, let's take two medians and then whatever is the meeting point. If we draw another line from A through that point, that line will become a median. This is what we'll do. Then we'll say that all three points are concurrent. Right. Let's continue. Now, BY is a median. What does that mean? AY equal to YC. Similarly, CZ is a median. What does that mean? AZ equal to BZ. Right. Let's do one thing. Let's take this BY median and draw a line parallel to BY passing through C. A line like this. A line like this. Right. Now, let us do one more thing. Whatever is the meeting point, right, of BY and CZ, two medians, let that be O, and let's draw a line connecting A and O and extend it further, like this. Right now, we don't know that this line AO is a median or not. We'll but let's just draw and try to see. Right. Let us just draw this line and extend this. And let this meet this line KC, which is parallel to KC, which is parallel to BY. Right. KC, which is parallel to BY, let it meet at K. So KC is parallel to BY. Right. Then let this meet at K. Right. Now let's take this triangle A AKC. Let us take this triangle AKC. Right. Y is midpoint of this triangle. Right. This side. Y is midpoint of this side. We are talking about AKC. Right. AKC. Y is midpoint and OY is actually parallel to KC. OY is parallel to KC. Right. Then what does that mean? A line is parallel and one of the points is actually midpoint. What that means, AO, this O is actually midpoint of AK also. Right. This is a basic elementary theorem that we already know. Right. There is a triangle. If a line, if we draw a line which is actually midpoint of one of the sides and parallel to this side, then obviously this also will become midpoint. Right. So O is actually midpoint of KK. How do we know this? Because this line is parallel to this line. What does that mean? This angle is equal to this angle, and this angle is equal to this angle, and this angle is common. So basically, we are talking about A, O, Y, and K, C. The triangles A, O, Y, and is similar to triangle A, K, C. A, K, C. Because all three angles are same. Now, AY equal to YC. right? Now, what does that mean? Because these triangles are similar and one of the sides are equal, that means these triangles, then the other side is also equal, right? AY equal to Y, so what does that mean? AO equal to OK, right? So, for example, AY by AC is equal to AO by OK is equal to R, right? Because these are similar triangles, AOY and AKC, AOY and AKC are similar triangles. If AY is half of AC, then AO is half of AK, right? Right. We have proved this. So now O is the midpoint of AK. Right. Let it be like this. Now let us take this other triangle A B K. A B K. Right. A B K. Now here Z is already center of AB. Right. Z is the midpoint of AB because this is the median. CZ is a median. Median touches at the center. Now, O is already midpoint of AK. Right, we just proved this. O is midpoint of AK. Now, ABK in this triangle, this line is actually joining midpoints of two sides. Obviously, what does that mean? This should be parallel to this one. Right, we already know this also. Right, line joining midpoints of two sides is actually parallel to third side. Right, we already know this. This is also one elementary theorem. Right. Line joining midpoints of two sides is actually parallel to the third side. So ZO is parallel to PK. So now we have proved this. ZO means ZOC. ZOC is parallel to PK. Now let's see this. We have just proved OC is parallel to BK. Right. OC is parallel to BK and OY or BY is BO, right? BO is parallel to KC, right? Because that's what we have started with. KC is parallel to BO because that is our initial drawing, and we have proved now this OC is parallel to BK. Now let us take this entire part, BOKC, BOKC. BOCK, sorry, BOCK. This is a parallel now, right? Because this line is parallel to this line, two lines are parallel, right? BO is parallel to KC and BK is parallel to OC, right? So that means BOCK, this quadrilateral is actually parallel. And these two, OK and BC, right? These two are diagonals. We already know in a parallelogram, the diagonals bisect each other. What does that mean? Bx equal to xc and yx equal to xk, right? Because this is a triangle, this is a parallelogram. Bx is equal to xc, ox equal to xk, because this is a parallelogram. Now, this is what we wanted to prove. Bx equal to xc. What does that mean? This part is equal to this point. That means this is the midpoint. That means ax is a median. This is what we wanted to prove, right? So AX is median, that is already proved. That means the line which is passing through this point O. This O is actually the point of intersection of two of the medians. So this third one is the line which is actually passing through intersection of two medians is actually a median. Right, because we have just proved Bx equal to Xc. So we have proved Bx equal to Xc, that means all three medians are congruent. The first part is done. Now, then we have also just realized Ox equal to Xc, right? Ox equal to Xc, and we have already proved that AO is equal to OK. Right, O is the midpoint of AK. Right, O is the midpoint of AK. So that means AO is equal to OK. This is one thing. And OX equal to XK. Right. So now if you see OX equal to XK and this point, this AO is actually equal to OK, right? So what does that mean? If this length is L, this length is L, this length is actually 2L, right? OK is equal to AO and OX equal to XK. OX equal to XK. That means if this is L, this is L. Right? OK is equal to AO. That means this is 2L. Now, what is this? What is this? O is dividing this AX in the ratio of 2L is to L, which is equal to 2 is to 1. This is what we wanted to prove, right? The centroid is dividing the median in the ratio of 2 is to 1. Right. Similarly, you can prove for By and Cz also by drawing similar parallelograms. Right. This is such a nice proof. Hope you understood this. This is very important. Right. So, with this proof, we can actually construct a triangle we are given only the medians. That we will pick up later. That exercise. This is a very important problem for Olympiads also. To construct a triangle when we are given its medians. Given its medians. This is a very important problem for Olympiads also. It was given, right? When given medians, how do you construct a triangle? We use this property only. We use this property of the centroid divides medians in the ratio of 2 is to 1. And using that property, we can actually construct the triangle. So constructing a triangle when given its sides is very easy, right? Two sides or sorry, three sides or two sides one angle or two angles one side. These things are very easy. But how do you construct when you are given medians, right? You are given the length of three medians. Then you have to construct the triangle. That is little challenging. We'll pick that up in another session. For now, in this session, we have understood the proof of how centroid is dividing the medians in the ratio 2 is to 1, and before that how the centroid or how the medians are actually concurrent. Nice. Hope you understood this. Thank you guys.